Okay, so this topic is called Understanding the 3D Shape of Molecules with Pi Bonds, and we're supposed to look at this structure and say, could it be this? Or this, or this, or this, or this, or this, okay? So I can see this is supposed to be a 3D structure because it's got hashes and wedges. And I know that if these two are sp hybridized, these are all planar. That is, if I take this structure, if I take this structure if I take that structure and put it in the plane of the paper, it's going to look like this. Right? And this is going to be a CH3. This is going to be a CH3. And this is going to be a hydrogen, and this is going to be a hydrogen, right? So if I'm looking at it, if this is a wedge, oh, I can see automatically this can't be right because it's got two methyl groups coming off of this carbon, and that does not. So this cannot be it. This one has got two methyl groups coming off of that carbon. That can't be it. This one has got one methyl group but no hydrogen. What's going on here? No, this can't be it. Okay, I better look at some more. Okay, now these are not 3D structures, so it's possible that one of these could be it. I hope something's it. But no, look, this has got two methyl groups coming off of. This has got two methyl groups coming off of this carbon right here. That can't be it. This has got, what is going on here? That can't be it. And that can't be it, because that should have a hydrogen, right? And another methyl group. Huh. None of those had 4 carbons in it. That's really weird. Okay, I'm going to click solve, because I'm not getting green buttons here. Sorry for the background noise. I'm sitting in my kitchen here. I'm going to click solve, and you'll see that none of these, that's going to click none of these, okay? I just clicked it, none, so that means we're right. Okay, let's try another one. I want to get one of them. Okay, so again, if this is sp2 hybridized, or rather, it doesn't matter if it's hybridized. I guess we can see that's sp2 hybridized. It's in the plane. Then what's going to happen is it's going to look like this. CH3, C, double bond O, hydrogen. There must be one lone pair of electrons here because there's a plus on it, right? Okay, but you can see that these are all constrained to the plane, no problem. Because this is sp2 hybridized, because it's got two bonds here. There must be a hydrogen here as well. Okay, so if that's true, these are all in the plane, and these are fine, except except this one's coming out toward me. This should also be either going back, right? It should be doing that, or coming out toward me. But this is not this. If this line, this is just a plain old line right there. That means it's in the plane, and this is coming out toward me. This can't be it. They all have to be in the same plane. Aha! Here's one. This is coming out toward me. So this is like flat table that I'm sitting at. That's coming out toward me. That's going back behind. This is legit. What about this one? This appears not to be a 3-dimensional structure. So I don't know if, let's look at the question. Does it have to be 3-dimensional arrangements? Select all the 3-dimensional arrangements on both sides if there are none. So this is not a 3-dimensional arrangement. I think this is not, I'm not going to get credit for that. So I'm going to click that. Not that one. Here's a 3-dimensional arrangement. And if that's coming out toward me, but that doesn't have another hydrogen on it. It's missing a hydrogen. So no, it can't be that. Here's some that are in the plane because they're flat lines, right? This one's coming out toward me. Can't be that. And this is not 3-dimensional. I'm going to say that's the only one. I'm going to click solve, and we'll see that this is the only one that shows up. And if I'm wrong, that means that I'm allowed to use structures that are not 3-dimensional, and this would be okay. And this would also be okay. Click solve. Okay, so we are being required to use three-dimensional structures here. I'm going to do one more, try another. My family is about to walk in the kitchen, and we are very chatty people. So you're going to hear some people in the background. Now these are all in the plane, and since there's a double bond here, this is going to be sp2 hybridized. That means these are all in the plane. So that means if I take this structure, and draw it like it's on a table in front of me, and the ammonium is coming out toward me, that's possible. In which case, there's going to be a methyl group going back behind, right? And there ought to be a hydrogen coming out toward me, and another hydrogen going back behind. That's what it ought to look like if I'm looking at it like, right? Of course, I could flip it over, and I could put the ammonium going back behind, right? In which case a hydrogen is coming out toward me. In which case another hydrogen is coming out. This is if it's on the table in front of me, right? Where my elbows are on top of that. Okay, that's a couple possibilities. This is not a three-dimensional structure. This is a three-dimensional structure. This is actually possible. Yeah, this is possible. I didn't draw the hydrogens out, but if we did that, this would be legit. This would work. Because the nitrogen, the carbon, all these atoms are still in the plane, and we just have some hydrogens coming out towards us. That's legit. I like that. This one's not a three-dimensional structure, so it can't be that. Let's look down here. Yeah, this is also, these carbons are all in the plane, and the hydrogens are not, so that could be it. So we're going to say that one, and not this one, though, because if these three atoms are in the plane, that one's also going to be in the plane. It's all one plane. It's all on one table, because this is sp2 hybridized. That means everything attached to this is going to be in the same plane, and that's not what this wedge says. And this would be legit. So this is not it. This would be legit, except that carbon's missing a methyl group, right? There needs to be another methyl group on that. So it's not going to be it. I'm going to click solve, and you'll see these two are the only ones that are possible. Okay. A model set is probably the only way to really get good at this one. I mean, you could get good at drawing them a lot, but you really probably need to see them three-dimensionally. Hope this is helpful, and good luck.